Centripetal acceleration is the acceleration of an object towards the center of a circle when an object is in motion around a circle at a constant speed. Centripetal acceleration is always directed toward the center and is perpendicular to the object's velocity. It can be defined using the radius and linear speed. A is equal to v squared, where A is the centripetal acceleration in meters per second squared. V is the linear speed in meters per second, and the radius is in meters. Using the equation relating angular speed and linear speed, V is equal to r omega, where omega is the angular speed in radians per second. These equations can be combined to give another form of the centripetal acceleration equation. A is equal to omega squared times r. Alternatively, since we know angular velocity is omega equal to 2 pi over t, this means that centripetal acceleration can also be written as A is equal to 2 pi over t squared times r, or 4 pi squared times r over squared. This equation shows how centripetal acceleration relates to the linear speed and the angular speed. Let's look at this worked example to get a better understanding of centripetal acceleration. A ball tied to a string is rotating in a horizontal circle with a radius of 5 meters and an angular speed of 1.5 radians per second. Calculate its centripetal acceleration if the radius was half as large and the angular speed was twice as fast. So here we have the radius and the angular speed, so we will use the formula A is equal to omega squared times r. Now, if this radius was half as large, we would have A is equal to omega squared times r over 2. And if the angular speed was twice as fast, we have A is equal to 2 omega squared times r over 2, which gives us A is equal to 4 omega squared times r over 2. And now we can plug in the values, which gives us A is equal to 4 times 1.5 squared times 5 over 2, which gives us 0.5 meters per second squared.